Series and parallel electronic circuits. This lesson reviews electronic circuits, introduces common circuit symbols, distinguishes between series and parallel circuits, and explores the behavior of current and voltage in each configuration. Electronic circuits. A circuit is a complete loop in which electricity can flow. An ideal circuit is any path in which electricity can flow from start to finish and pass through a load, where the energy is put to use. This load can be almost anything that uses the power, such as a light bulb or LED. Circuits for lights are usually fairly simple. A power supply is connected to both terminals on a light source, and then electricity is allowed to flow through it, which completes the circuit and turns the light on. Common symbols used in circuit diagrams. Here you can view different electronic circuit symbols. It categorizes various components like resistors, capacitors, inductors, diodes, transistors, and more, along with their corresponding symbols. This visual aid is invaluable for anyone working with electronic circuits, as it helps in understanding and interpreting circuit diagrams. Series circuit versus parallel circuits. When building a circuit, there are basically two ways in which you can connect a load. They can either be in series or parallel. When you wire electrical components in series, they are in a line. So, if you were to break the circuit in any way, for example by unplugging a light bulb, electricity has no path to continue flowing and the whole connection is broken. Alternately, you can prevent this problem by wiring the light bulbs in parallel. When wired in this way, they are connected side by side and share the same electrical connections on both ends. As a result, when you unplug one bulb, electricity can continue flowing through the other one unfettered. This table compares series and parallel circuits. Series circuits. Voltage is the sum of all components. The current is the same throughout. Resistance is the sum of individual resistances. If one component fails, the entire circuit stops working. Parallel circuits. Voltage remains the same across all components. The total current is the sum of currents through each branch. Resistance is calculated using the reciprocal formula. If one component fails, the rest of the circuit continues to function. Current and voltage in a series circuit. If we add more LEDs directly to an existing simple LED circuit in a single path, this configuration is known as series circuit, where there is a single path for current to flow from the positive side of the battery to the negative side, and thus the amount of current through each component is the same. In tutorial, LEDs barely turn on because they have a forward voltage of 2V approximate. That means for 2 LED total voltage drop of 4V is required, which is greater than our current 3V battery can supply. Check out the multimeter readings. The voltage from the battery is currently being split across the two LEDs, providing only 1.5V to each, when they require 2V to light up. This is why there is no current flowing through the circuit, 0A. Current and voltage in a parallel circuit. When LEDs are arranged in parallel, you can notice how each LED has one leg that has a path to the negative side of the battery, and another that has a path to the positive side of the battery. When components are arranged in this way, the current from the battery splits into each of these paths, while the voltage across each LED is the same. Click Start Simulation to test the circuit. Notice how all the LEDs can be powered in this way. Let's measure the voltage across any of the LEDs using a multimeter. Add a multimeter by clicking on Components panel, clicking on the multimeter, and adding it to your circuit. Connect one leg of the multimeter to one side of the left leg of an LED, and the other end to the right leg of the LED. Make sure that the multimeter is set to measure voltage by clicking on the V button on the multimeter.